Hello students, welcome to the world of chemistry. Chapter 6 Thermodynamics. This is the e-content lesson 12. Learn and enjoy chemistry in a simple way. Today we will learn about the fourth thermodynamic function, Gibbs free energy. Have you heard about the term Gibbs free energy? Which letter denoted by the letter Gibbs free energy? Capital letter G. Can you give the first four thermodynamic functions? The first thermodynamic function is delta U, internal energy. The second thermodynamic function is delta H, change in enthalpy. The third thermodynamic function is delta S, the change in entropy. The fourth thermodynamic function is Gibbs free energy, delta G. The first delta U, internal energy. Second delta H, enthalpy change. The third delta S, entropy change. The fourth delta G, Gibbs free energy. In this module, we will learn about Gibbs free energy, delta G. Students, what is the limitation of entropy, the criteria for spontaneity? In order to decide spontaneity of a process, we have to consider the change in entropy of the system as well as entropy of the surrounding. That is delta S total greater than 0 or delta S total is equal to delta S system plus delta S surrounding greater than 0. Students, however, the surrounding entropy are very fast. So, it is not easy to determine the spontaneity. So, we introduce a new thermodynamic function, Gibbs free energy delta G, which can be applied to the system only, but it taken into account the change of entropy of the surrounding. Can all the energy contained in a system can be converted into useful work? No. Some energy is utilized for the temperature or randomness in a system. Students, can you give the mathematical representation of Gibbs free energy? Capital letter G equal to H minus Ts, where S stands for enthalpy change of the system, S stands for entropy of the system, T is the temperature. From this equation, H is the useful work and Ts is the non-useful work. Students, can you define Gibbs free energy? Yes, it is defined as the maximum amount of energy available in a system that can be converted into useful work. That is, it is the capacity of system to do useful work. Students, then what is Gibbs free energy? It is a measure of system ability to do useful work. Here, some heat energy is used for the temperature and disorder in a system. Can you give the equation of Gibbs free energy? G is equal to H minus Ts. Equation number 1. What is the equation for capital H, enthalpy? Enthalpy H is equal to U plus PV. Substitute for H in equation number 1. Therefore, G is equal to U plus PV minus Ts. Equation number 2. That is, change in Gibbs free energy delta G is equal to delta U plus delta PV minus delta Ts. The change in Gibbs free energy at a constant temperature and pressure. that is delta G Tp equal to delta U plus P delta V minus T delta S. Since V delta P is equal to 0 and S delta T is equal to 0. Therefore, equation become delta G is equal to delta H minus T delta S. This equation is known as Gibbs-Helmholtz equation. What is Gibbs-Helmholtz equation? Delta G is equal to delta H minus T delta S. Can you explain the physical significance of Gibbs free energy? Can you give the first law of thermodynamics equation? Delta U equal to Q plus W, equation number 1. Here work involves expansion work, that is pressure volume change PV, and non-expansion work. Therefore, delta U is equal to Q plus work expansion plus work non-expansion, equation number 2. Since work equal to pressure volume change, that is work W is equal to minus P delta V. That is at a constant pressure, delta U equal to Q minus P delta V plus work non-expansion. Therefore, Q is equal to delta U plus work non-expansion. That is Q is equal to delta H minus work non-expansion, since delta U plus P delta V is equal to delta H. For a reversible process, delta S is equal to Q reversible by T. Substitute for Q reversible in equation. T delta S is equal to delta H minus work non-expansion. Therefore, work non-expansion is equal to delta H minus T delta S. That is, work non-expansion is equal to delta G. That is, delta G is equal to work useful. That is, work maximum. Here, Gibbs free energy decreases in a system for a spontaneous process. How Gibbs free energy becomes spontaneous? What about the value of delta G? Delta G is negative for a spontaneous process. If delta G becomes positive, the process is non-spontaneous. And delta G equal to 0, the process is equilibrium. Then we can do an assignment. Give the relation between delta G and delta H. Can you give the equation? That is a famous equation you have learned. Can you give the name of equation? Gibbs-Helmholtz equation. Delta G is equal to delta H minus T delta S. Question number 2. Give the relation between Gibbs free energy and equilibrium constant K. Can you give the equation? Delta G is equal to minus 2.303 RT log K. Can you give the relation between delta G and electrical work done in a cell? Can you give the equation? Delta G is equal to minus NF E0 cell. Give the equation for standard Gibbs free energy. Standard Gibbs free energy delta G0 R equal to sigma delta G0 F of P, that is product, minus sigma delta G0 F of reactance, that is reactance. This is the equation for standard Gibbs free energy. Thank you, students. You have all clear idea about the fourth thermodynamic function, Gibbs free energy. Learn well and revise the content lesson. Thank you all.